Smartphones are wonders of miniaturization. Complex topographies on the micro scale, like miniature Fresnel lenses, cannot be made with traditional methods. Maskless grayscale lithography is the enabling technology for such breakthroughs. Another example are diffractive optical elements needed for gesture recognition, or micro-lens arrays in heads-up displays. The designs can be stored in various formats. Image formats are easy to make in standard image editors. It is also easy to generate images with scripts that apply mathematical formulas. Families of similar geometries can be produced by modifying a few parameters. As one element of our demonstrator, we have chosen this Fresnel Vortex Axicon, 20 micron high. 3D objects can quickly and intuitively be created in a CAD software. Here a pair of concave spherical lenses cut into hexagons. In our conversion software, these lenses can be repeated to form a microlens array. Our HiConvert 3D software converts the designs to machine data. In this example, we will combine the microlens array, the Fresnel Vortex Axicon, and our logo. Parameters can be set to define the right mode, the size of the array, the dynamic range of the gray values, the offsets between the elements, and the writing strategy. Before we can make the exposure, we need to coat a substrate with light-sensitive photoresist, in this case a low-contrast positive resist, followed by a heating step to evaporate the solvent. The Heidelberg Instruments DWL series is our product line optimized for grayscale lithography. The control software of the DWL allows us to select a few parameters like laser power, focus position, and intensity correction. These are useful to optimize the exposure result. Without intensity correction, the shape of the exposed structures would not be correct, as the resist has a non-linear response. Alternatively, the non-linear response of the resist can be compensated with the software called Beamer from Genesis. This method also compensates for other proximity and non-intuitive effects. When the exposure job is set up, we can move the stage to the loading position. The substrate is placed onto the stage and fixed with vacuum. It is centered and the right head focuses on its surface. The DWL is now ready to start the exposure. The design is exposed in stripes. When the exposure is finished, the substrate is taken out and placed in developer solution. The partially exposed photoresist is removed during the development. Then the substrate is rinsed and dried. The structures are now ready for inspection. A standard optical microscope is limited to viewing from the top. A confocal microscope offers the ability to measure a 3D topography. The measurement output is a 3D surface. The measurement is also used to optimize the exposure by comparing the measured cross-section with the target profile. Analysis of the structure can also be done in a scanning electron microscope. We hope you enjoyed this quick overview of microfabrication with maskless grayscale lithography.